This machine is a Weldplas HQC precision plasma cutting system. It's a single unitary construction, so it's all in one big lump. It's mostly aluminium fabrication for the moving parts, and it's equipped with high-performance AC brushless EtherCAT servo drives with precision gearboxes. We go to a lot of trouble in the design of this machine to make it stable at speed and to give it the ability to accelerate and decelerate rapidly. This gives better performance on small holes and diameters and angle changes with less ringing, less potential for ringing and rounded off corners. So the linear slides and the rack is located underneath the skirt of the machine, out of the way, with the teeth arranged facing outwards, so they are not inclined to pick up any dirt or bits of dross sticking there during the piercing action. Likewise, the rack and pinion around the back of the head, this is arranged with the teeth facing outwards, so any dross that's expelled during the piercing process doesn't collect in the rack and therefore cause premature wear of the rack and the gear. You bear in mind that the product expelled when you're plasma cutting is very hard steel, so that will tend to damage the rack and pinion rather than itself. The machine's equipped with 3 AC brushless EtherCAT servo drives mated to precision planetary gearboxes. These are all 3, 2 in either leg and 1 on the top carriage. These are mounted on a pair of linear slides to allow them to push in and out of the mesh. We have a pneumatic ram behind that pushes the motor into mesh, acts like an air spring. The reason we do this is you can then set the air pressure on a gauge. So rather than adjusting a nut till the spring looks about the right tension, we can actually set a number on this. So we set these to about 2 bar. So 2 bar pressure pushes the motor into mesh. Because it's on a pair of linear slides, it can't twist. So there's an equal amount of force on the motor, whichever direction it goes in. There's no tendency for it to climb out. The other advantage of this is if you turn the air off, you can push the motor out of the mesh, and then you can freely move the head up and down to check the bearings. So this is a good idea to do occasionally to make sure there's no buildup of muck or anything, and to see if the bearings need greasing. They do occasionally need greasing depending on the environment the machine's working in. As a machine is designed specifically for plasma cutting, we want to be able to achieve the fast acceleration and decelerations required for the process. So the cutting head here is mounted, has a pair of linear slides, 1 on the top, 1 on the back. There are 3 blocks run on this in total, and the head itself is a complete wraparound design, so it comes underneath on a piece of 20mm aluminium plate and up the front. So we don't have the front of the head able to wobble around at all, so it keeps it very stiff. Plus it's got, as mentioned, the motor pushed into mesh all the time. This gives a very rigid structure. The side plates are 20mm thick water jet aluminium. We cut these on our own water jet machine down the bottom of the workshop. They are then powder coated and we assemble them onto the machine. Ideally, the advantage of water jet cutting is we can put every hole in, so there's no drilling required. And through the 20mm thick plate, we can stick a 4.2mm hole and open it out with a battery drill, tapping a battery drill. The side plates add to the stiffness of the machine. They're not just decorative. So the function of those is they basically effectively increase the width of this plate. So it means that this way the machine is very stiff. We do need a little bit of compliance in there, the machine, as it drives up and down, because we've got a drive motor in each leg. We don't want these to fight and overload. So there's a little bit of compliance in this way, but very stiff side to side. So as the head accelerates and decelerates, it stops quickly. It doesn't cause the machine to vibrate at all. So very important, stiff structure, extra beam at the bottom to encourage that stiffness. These are all heavy-duty aluminium extrusions. The Z-axis is built into this unit here. We have a number of systems for plate detection. So this has got automatic plate detection. This one works on a touchdown and a floating head at the front, the touchdown switch. We have another system that uses the same mechanics, but also has a touchdown wire. So if you're cutting thin material, it'll use the wire to detect the material rather than the weight of the torch. So that's useful for thin material. Everyday cutting uses this one. And if you're cutting a lot of HVAC type, heating, ventilation, duct type stuff, then we have a floating head assembly and a machine with a lower beam because we're looking for faster dynamic faster speeds. So we have a lower beam, and we have a plate riding roller, which is pneumatically driven, drives down, air pressure, drops it down onto the plate, and it then just follows the plate. We use that for those systems because the plate can flex so quickly, so thin, that you don't have the complexity of a height sense working at very high speed. The cutting beds are available in 3 flavors. This is a zoned fume extraction bed. It has a set of dampers down the inside of the bed connected to a duct at the back. The dampers are controlled by the CNC system, so we don't have a big spike coming out here to operate them. So the CNC system opens and closes the dampers as the machine moves up and down the bed. We can program some overlap in there, so it gives time to fully extract one compartment before closing it. Option 2 is a water bed. So the water bed has a tank in here which is about 200 millimeters deep. That's got a considerable weight to it, so we mount an independent frame inside the bed which takes the weight of the water bed and connects through holes in the base of this fabrication through to the floor, so the weight of the plate's not taken on the machine. Option 3 is single point fume extraction. We'd use that for HVAC type stuff where they're always putting a sheet of 8x4 galv on there every time. Because it's got good coverage, you then don't need to zone it. So a single point, single hole at the back, single extraction works for that. Part of the remit when we first designed this machine, which was maybe 10 years ago, was to make them as easy as possible to manufacture, and also use the processes that we ourselves sell to manufacture the machine. It seems to make sense that if you sell CNC equipment and water jets, then you should use them in the manufacture of your machines. So this is a typical component. This is the head plate that goes inside here. 20 millimeter thick aluminium, as stated earlier. It's got 4.2 millimeter holes in there. So we can tap these out with a battery drill, tapping the battery drill. These slots echo the profile of the slots in the extrusion. So we can use extrusion nuts, pop those in there. That means we no longer have to drill and tap into the end of these, which is a bit tricky to do. So we just slide a T-nut in there. There's space for 2 T-nuts. Because this doesn't give much in the way of location, we're going to have a location tag here, which fits in a square hole in the next bit of plate. So really, the idea behind this is to remove as much labor as possible, remove any drilling, time-consuming drilling, and also the possibility of getting it in the wrong place. These holes here are hexagonal. They're like that because we have a sensor that goes in there with a hexagonal nut on it. So that's the same size as the nut. So now you don't need to get a spanner on both sides. You can just, the nut's locked in there, and it makes it easier to assemble. An open slot, so we then don't have to feed the thing in. Makes it easy for maintenance. So we try to cover most aspects of the machine design to make it easier for manufacture and easier also for maintenance and support. You can see here in this shot the rack mounted at the rear of the machine with its teeth facing outwards and the 2 linear slides which make this a very stiff construction. Somewhat harder to see, but here's the pneumatic ram in one of the legs with the motor behind it and the gearbox behind that. All our machines are equipped with a magnetic torch breakaway. This is this device here, torch mounts on the front of it, and there are some inductive sensors on there, so if the torch is caught, then the machine will stop and put up an error. This is one of the drive motors. This is a 400 watt AC servo motor. Made by our friends Trio, who are based in Tewkesbury down near Gloucester. This is a kit of parts to form one HQC machine. So these are the water jet cut aluminium parts, post painting obviously. And we see there's quite a lot of small components, lots of holes, and the only manual intervention really on these so far has been to give them a quick whiz with the sander, just to remove any burrs on the edge of the cut. This is a typical mounting plate. This is actually for the pneumatic ram on the top axis, I think. But we can see it's a finished components. lovely finish. Because it's all done in-house, we've got control over the sort of the production and the quality of these items. If we find anything that's not to quality, then we've only ourselves to blame. And if we need to make another one, then we can make one almost instantly. That'd be 15 minutes for this component. This is the cutting bed. It's fresh in from the powder coaters, and we've just started to assemble the other components onto it. So it has the linear slide and the rack mounted already. It's awaiting der bar and obviously the machine fitting. We can see the slide blocks in here. So a pair of slide blocks either side. And this is a zoned bed, so we have our zoned distribution valve there. The mechanical aspects of the machine are really only part of the story. Perhaps more important is the control system side. So this Trio Motion Technology motion controllers. This box is hopefully a Flex 6 Nano, which is a 64-axis, 64-bit motion controller. So it comes as a slice. So this is the unit itself. So as I say, it's 64-bit motion control. It's EtherCAT, so the drives connect to this Ethernet connection here. So rather than using analog connections, everything's done through the EtherCAT system. So this controls the drives. Yep. One of the advantages, well, many advantages. One advantage is less wiring required on the machine. Another advantage is extremely high speeds in the order of microseconds. So tiny thing, that'll do 64 axes. Our machines use 4 axes, so this is well within its capabilities. So the Flex 6 Nano motion controller communicates the AC brushless drives. It's one of these fellas in this box. Have a quick, can't get the warranty sticker off. Slightly embarrassing. So this is a 400-watt servo drive. Here we have the in and out connectors for the EtherCAT. So they connect to the Flex 6 Nano. Safety circuit on the front and a bit of I/O and power on the top. So nice, neat unit. 3 of these in each machine. And we'll have a look at the motors next. Next up is a drive motor. I've already taken the sticker off this one. Make it easier to get in the box. So a compact little unit, but this is a, as it says in the label, 400-watt servo drive, 200 volts. This gives 3,000 RPM and 1.27 Newton meters torque out the end. So high torque, high speed. We'd use these on the bigger machines rather than stepper motors because these are 3,000 RPM, whereas the stepper motors generally only 1,000 RPM. So we can couple these with a 20-to-1 gearbox, gives us lots of torque, better accels, decels for going around corners and the like. So that's quite a bit of torque in there because it's quite a meaty shaft under there. So these are quite expensive actually. Servo motors are linked to a final drive-through gearbox. So it's a Nougat gearbox. This is a PLE 60, so it's 60 frame and it's 15-to-1 ratio. So this is a thing of mechanical beauty. Again, this is planetary. This is low backlash, so this has probably got backlash in order of 15 arc seconds or something along those lines, I think. Maybe 30 arc seconds. But that makes to our servo box. So we can see on this machine we've got quite a high spec drive system. These are made in Germany, of all places. So a quality drive system, again for greater torque, better acceleration, deceleration. and a considerable uplift in cost over that of a stepper drive. This is a typical stepper drive amplifier, and they're a fraction of the cost of the servos, but we believe it's the quality we get from the cut is worthy of the extra cost. So I've opened this one already because it's quite challenging to get it out of the box. So this is a Lilliput touchscreen monitor. So it's an industrial touchscreen monitor. Fairly well sealed, got a few buttons on the back. We mount this in an enclosure, plenty of options at the back for control. But we use a touchscreen monitor rather than an ordinary desktop monitor because the touch facility is very useful when controlling a machine. If you want to do something quickly, you just press the button on the screen rather than using the mouse and trying to find out where the mouse has gone and pull the mouse into the bottom corner and then try and click on things. This way is much quicker, much easier to use, and we're not worried about the mouse filling it with dirt and having to have a little keyboard arrangement. It's very robust and work extremely well. And lastly, for our unboxing session, we've got a PC. So this is a Dell Optiplex B15U. Optiplex 7010. So this is an off-the-shelf PC, as you can see, it comes straight out of the box. We don't do anything to it other than put software on. We think it's very important that we use the standard hardware whenever possible, because if you have any problems downstream, then it's easy to rectify. So it's just a brief overview of the Weldplas HQC machine and its construction. So it's a robust, high-performing machine made in Britain, where there's many locally sourced parts as possible, with our own CNC control system. There are several videos of the CNC control system working, but it in itself is designed to be easy to use, friendly to use, and performs extremely well. It has several special functions in there for cutting holes, so we get excellent quality holes on most materials using an air plasma. And really, plasma cutting, it's all about the holes.